Okay, in this problem we have a projectile that is shot from the top of a hill. It leaves in this manner. It goes up, gets to a high point, and from there it starts descending, goes all the way to the bottom where it's gonna hit the ground. Okay, and this problem is asking us three things. It's asking us the time where the projectile is gonna reach the maximum point. It's asking the height where the maximum point it will be reached, and it's asking us the time at which we will hit the ground. The projectile will hit the ground. It's asking us these three things. We are also given the height in the terms of time, a function, quadratic function, which is a parabola. We'll make a little sketch. Okay, and a parabola that's gonna look something like this, with a vertex here, x and y axis, and there you go. And the x for us will represent time, and the y will represent for us the height. The function of h will be determined by the time that's down here on the x-axis. Okay, so we're gonna find first the time that it takes for the projectile to reach the vertex of the parabola or the maximum point. So for this we're gonna use the vertex formula of a quadratic function, from which, if we write it out, I'm gonna copy it here so I can make some notes on it. Okay, this is our vertex formula. Okay, so here this is the x coordinate, for which for us that would be the time, and this is the y coordinate for us, which is the height. Okay, so there you go, the time. Let's find our time first, and this would be simply calculating this value, negative b over 2a. We're gonna plug in and find it. Negative 10 over 2 times a, and a is 4.9, negative 4.9. There you go. The two negatives cancel each other out, and we will have, let's calculate it to 3 sig figs, 1.02 seconds. This is the time where the projectile will reach its maximum height. Now let's calculate the height at which the projectile will be when it reaches the maximum point. So for this we will plug in this value into the function. So we got 1.02 seconds. We're gonna plug it into our function. F of 1.02 seconds will be equal to, let's plug it in, negative 4.9 in the parentheses. Oh, let me open this up, because see, I have some other stuff written there, so let me just do it this way. 4.9, and we're gonna have 1.02 seconds on the square, then plus 10 times 1.02, and then plus 200. 200 is basically the height from which the projectile was initially shot from. Okay, and if we calculate this value, we will get a maximum height of 205 meters. I'm also gonna do this to 3 sig figs, just like we did this one. Okay, now the final question of the problem is that they want to know the time at which our projectile will hit the ground. So if we look at our mathematical version of the parabola, what is the point at which the projectile will reach the ground? Well, it's height of 0, right? And that would be down here, exactly at the x-intercept. So mathematically, we need to find the x-intercepts of this parabola. Therefore, we're gonna take this function and put it equal to 0. So C, we will take 0 equal to the whole function, negative 4.9 t on the square plus 10 t and plus 200. And simply using the quadratic formula, we're gonna find 2 t's, and 1 t will be negative 5.45 seconds, and 1 will be 7.49 seconds. Now, mathematically, both of these make sense, and we have one intercept here and one intercept here. But in the physical world, we know that there's no such thing as negative time, so therefore we're gonna simply disregard this one, and we know that the time that it will take for the projectile to reach the ground, it is right here, 7.49 seconds.